So you make up this, he has given so many things, C1, C2, A, B, the point of intersection, and this is D and E. Okay, now you go back to motional EMF. Directly take help of motional EMF. That'll be better, easier one. No? So this will be the triangle is what we'll get it. Check it. So shall we write this as say some theta? Or total angle is theta. Theta by 2, theta by 2. We know radius r. Can we get the length AB? 2r cos theta by 2. The length AB is equal to 2r cos theta by 2. After this, what we have to do? This about the mathematics is what I am bringing the thing. So from the triangle AB, what we can write it as 2r cos theta by 2. I'll write alpha because flux will be using no symbol. How to calculate the EMF induced everywhere B is into the plane. What to do when you get a situation like this? See, like you treat this is one arc, this is one arc, this is one arc, this is one arc. So we know that what to be the length. Effective length is what we should go know. So what is the EMF induced for EADB? EA, like a yellow color ring, or so this will write P1. What is the EMF induced of all these elements? Will be same. So can we also predict the direction of induced EMF? Can we also predict the direction of induced EMF? Yes, we'll apply the Lenz's law and we'll get the direction of induced EMF in each. These things I will take it out. Let's indicate the EMF induced in those things, or we'll give the name 1, 2, 3, 4 like that. What about the B bar into the plane? It is a yellow color rod is moving towards left. So B bar velocity. So this should be the positive. So the polarities will be here in this way. We'll give name, some simple names like a E4, I'll write it. Now what about this? This will be E3. So this will be E2. Actually, I have to show it here. Okay, for this, I'll show it here. Okay, no problem. Okay, you are telling sir why off that one. So here, these are the, so call them as E1. This is E. This we give number D. So many symbols again here also. What about the magnitude of all these EMFs? Will be same. E1 equal to E2 is equal to E4 is equal to B V into length. Length is how much? 2r cos alpha by 2. I think your problem is solved once you are here. Now, what about the current? And all are having their resistance per unit length is also available. How to get the direction of flow of current? All are having, they're having same EMF. So how your circuit diagram? So if you find very difficult, no, better jump into the circuit diagram. So the resistance of this, I'll show it here. The resistance of this along with this cell. These two will have same resistance. I'll call them as R3, R4. Same symbols will stick on. So this will be E1, R1, E2, R2. What about the resistance R4 and R3? arc length. We have to take help of that arc length, no? And whatever the resistance, here I think I took symbols here. What is the resistance of like this AP1B? I think it should be equal to arc length of this one. So what is the angle subtended by the arc? Alpha, alpha into R. What is the radius? Radius is A, no? Oh, I think I'm, R is the resistance. I changed it. Huh? Okay, now get into the discussion now. Now this will be, what is the resistance R3 and R4? R3, R4 should be equal to, arc length should be equal to A alpha into lambda. What about the resistance R1 and R2? Should be equal to 2 pi minus alpha, this is the angle, into A into lambda. What about the current? How the flow of currents we have to take it? I think you directly come, forget about EMI. The EMI is over. No, the flow of currents, I'll do one thing. Here, one current will flow that will take capital I, and the capital I will, this is very important. The circuit, if you draw, you are okay, fine. Otherwise, you are gone. And what about the other current? The other current will be of like this, small I. Able to notice this one. So what is I is equal to? I think if you write the I is equal to, it will be E3 plus E4 plus R3 plus R4. And the sum of that should be equal. So therefore this will be 2 into BV. Okay, that 2A cos of alpha by 2 by R3 plus R4. So this will become 2A. This is a current I. Similarly, expression for current capital I will write it. So that should be equal to E1 plus E2, R1 plus R2. So E1 plus E2. So this will become 2BV into A lambda. The force on any circular ring at time t, the current in the branch BDA of the ring. I think it was asked. So now substitute the value of alpha and work out here. AC1B. So it is asking this current I. BDA. The current in the branch BDA. Where is the B? B is here. I'm not seeing B symbol. B. DA is asking this capital I. So is it okay now? Substitute the value of alpha. Alpha is 60 degrees. Here also, alpha you substitute in radians. Shall I pick up option C? Let me solve it. I is equal to 2BV. A cos of, this will be root 3 by 2, 60 degrees. So this will be root 3 by 2, 2 pi. This will be pi. How much will get? This will be pi by 3 into A lambda. Check calculation once. Is it 4 BVA? So this will be 665. 5 will come. Lambda will be there. A will get cancelled. Root 3, yeah, we are getting. Okay, we will see why any corrections are needed. So this will become 3 5 pi. 2 6 BV 6 root 3 BV by 5 pi lambda. Am I right? Check calculations.
Sir, in the denominator, we should multiply with 2, no, sir?
Ah, yeah, 2 is there. No, 2 I brought it. No, 2. 2 is there. This is what EMF induced. No, I multiplied 2. I added up 2. No,
No, sir, in the equation of capital I.
there also same thing like a E1 plus E2, 2 times of.
For R1 plus R2, sir?
Oh, the denominator 2 is needed.
Yes, sir.
Oh, yeah, missed 2 here. No, and the 2 gets eliminated. I think this 2 will not be there in the next step. In the next step, this 2 will not there. So here it will be 3 will come then. 3 root 3. 3 root 3 BV by 5 pi lambda. AC1B is 60 degrees. AC1B is 60 degrees means alpha 2 will be 30 degrees. Yeah, cos 3 by 2. Root 3 will come. We'll make this as an option. Huh? Then there's the problem with the options are there. I'll make correction here. 3 root 3 BV by 5 lambda. Oh, no, force on the circular ring. Force on the circular ring at time AC1B. It's asking the force on that one. I think that I should come here. So what is the magnitude of force? F should be equal to B into I into, we know length. What is the length? Into effective length will be AB. So this will be B. What is the value of I? I will be 2BVA. A also gets eliminated. 2BV cos of alpha by 2. 2A gets eliminated here. So we'll be left over with alpha lambda. This is B. And what is the length of this will be? 2A cos alpha by 2. So this is the force on AC1B. Uh, 2B, here also 4 B square B cos alpha by 2 cos alpha. Any value shall I write final? Root 3 by 2, root 3 by 4. Okay, this will become 3. 3B square V by alpha lambda. A should be there, no? Why A gone? 1 A will be there here. 3B square AV by lambda. Okay. Check calculation. I'm just give the idea. So this is what I feel the answer. Effective length is what we have to take it here also. Effective length will be 2A cos alpha by 2. I think I have to change this also option.